So here we have a problem from 2017. It's problem number 2, so it's calculator required. And just by glancing at it, I'm not really sure what kind of problem it is. Let's go ahead and read it. This is going to be a problem for you to try as well, because I've already given you 2 videos. When a certain grocery store opens, it has 50 pounds of bananas on display. So we already have an initial condition. Customers remove bananas from the display at a rate modeled by this thing right here. And so already by reading that, this is an in and out problem. In and out problem, because we have things apparently coming out, right? We have bananas that are leaving the table. We might even eventually have bananas that are being put on the table. So we only have it from time is 0 to time is 12. And I like to label these, so this is bananas displayed. Remove. I have a tendency to forget what it is, and since they didn't label it R of t like remove, I like to just label it so I'm not grabbing the wrong equation. Okay? So this is bananas. There's 50 pounds already sitting there. People start coming in, and bananas are removed. F of t is measured in pounds per hour, so we're talking about pounds, and t is the number of hours, pounds and hours, after the store has opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by, and here is the second part. This is being placed on there. So this is the in, removed and added. So this is the rate at which bananas are added, the rate at which they're removed. If I integrated either of these, then I could figure out how many were actually removed, or how many pounds rather, and how many pounds were actually added. So there are 4 parts of this. Let's read the first one. How many pounds of bananas are removed from the display table during the first 2 hours? So I'm using the removed one, and I'm going to integrate, right, to find the number of pounds. I'm going to integrate f of t from the time that we know, time is 0, all the way to time is 2. And you want to make sure that you use the right notation with the f of t dt, because that's worth a point right there. Now you have to actually do it to figure out the number of pounds. So pretty straightforward, use a calculator. Next part, find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. So you're gonna go, if you have a TI-84, second calc, you're using this guy right here. So we're still talking about removing, and that's what you're gonna have to include in your context of the problem. It's gonna be the rate of the rate. This is a rate, and we're taking the derivative of it. So the rate at which they're accelerating or something like that. But you're going to have to talk about, you have to use the words pounds, and you have to use the word hours. So on a calculator, you're going to go ahead and take f of t, type it in, graph it, and then take the derivative and plug in 7. Plug in 7. So I want to say that's second calc, let me see here, second calc, and then it's option 6. Second calc 6. But you will have to box up that answer when you get the number to 3 decimal places with an explanation in the context of the problem. Okay? All right, next part, C. Is the number of pounds of bananas on the display table increasing or decreasing at time equals 5? Give a reason for your answer. So if the pounds are increasing, that means that, well, we already have rates, right? We just need to figure out which rate is higher at time is 5. So we're only looking at time is 5 right there, and we need to figure out whether f of t is bigger than g of t, or whether it's the other way around, whether g of t is bigger than f of t, whichever one's bigger, and f of t is removed. So if it's the first situation, then more bananas are being removed than are being added. That means the number of pounds of bananas on the display table would be going down, right? And if it were the other way around. So maybe get a graph, plug in, would be both good ideas. You just need to plug in 5, and those are the rates. Remember, we're trying to figure out whether this rate is bigger or that rate is bigger. These functions are of rates. And last one. How many pounds of bananas are on display on the display table at time t equals 8? Okay, so this is the last part. Time t equals 8. So the first thing we're looking at the number, so I automatically want to start with my 50, and then all the way to 8. From 0 to 8, bananas are being removed, right? The whole entire time, bananas are being removed with that function, okay? I just need to look at the function. I haven't graphed it or anything like that. Since this is removed, I might need a minus sign in this spot. Just what I'm thinking about it. If they already had the function as negative, then the negative was already incorporated into it. So just be careful with that sign. You need to look at the actual graph, which I haven't yet. That's why I'm just giving you recommendations on this problem. So you start with 50, then bananas are removed, and then bananas are also started to be added, right? So we also have adding bananas, which only starts at time is 3 going all the way to 8 for g of t dt. Right, so think about that, actually do it, figure out what the answers are, and check your answers on College Board's website. All right, good luck.